comparison of EMF, EMFs of two cells. Comparison of EMF of two cells. Okay, this is the other knows. So first we have to know the diagram. So this is a switch state and main primary circuit, the battery E. This is called AB, the potentiometer wire. AB, the potentiometer wire. This is called primary circuit. This is called switch state. Now I want to compare the EMF of two cells, means which I am going to connect two cells of their EMFs. This is the E1, this is the E2 with a two-way switch. This is the two-way switch. Two-way switch of it. So this is the E1, this is the position 1, the E2 position 2. Second, for position 2, E2 EMF. So this is the now we have same thing, galvanometer, the resistance box RB, and then suppose when the switch is at position 1, then move the jacket from A to B, and one of the instruments say the length point P, the length is L1. The length is L1. Why? The galvanometer shows zero deflection. The galvanometer shows zero deflection. Next, the position 2, same way, again move the galvanometer, again move the jacket from A to B. So this is the. Now I am going to move the jacket from this position. This is what is jacket. Now the galvanometer shows zero deflection at a point Q. You can put your own number. This is L. So the galvanometer deflection becomes zero. Then this is a balanced one. That length is L1 due to E1. When the switch, then called a two-way switch. Position 1, L1. Position 2, L2. So then that is E1 is directly proportional to L1. Similarly, E2 is directly proportional to L2. Okay, sir. By dividing equation 1, if you want to remove the proportionality, you get some constant. That is called K. This is also K. Okay. Now based on this, so E1 is equal to KL1 and E2 is equal to KL, constant. Or sometimes you can say pi also. So what is the unit of K? What is the unit of K? E1 is equal to K is a constant, L is the length. What is the unit of K? E is the EMF. Unit of EMF is volt, length is meter. So K unit is equal to volt per meter. So volt meter length unit also. Okay. Now by dividing equation 1 by 2, so this I call this as equation 1. I call this as equation 2. All of understanding up. Now all of you know this general formula. Everybody knows it commonly. Now by dividing equation 1 by equation 1 divided by 2. So we get, so very simple, easy. Therefore, E1 by E2 is equal to L1 by L2. This is the formula what we got. This everybody knows this is the common formula. Now, up here copy all of you. Everybody knows this formula. So comparison of EMF of two cells. E1 by E2 is equal to L1 by L2. Okay, well and good. Now, what I am going to do next one is, now when next say case 1, when EMFs are additive. That means when they are connected in series, they are additive. So at that time, then I can make this is the, when negative terminal is connected to positive, then we call it adding only E1 plus E2. So then by connecting the same thing to here in place of this fellow, there is not a two-way switch. I'm connecting E1, E2, the EMFs are additive. Then the length which is going to get the balancing length is, again I have to draw, no need to draw the diagram. In place of this, I'm drawing E1, E2 in series and go to the galvanometer. Then moving J from point A to B, at one of the instant the galvanometer shows zero deflection. Then that length, then this length can be equal to, that is E1 plus E2 is equal to KL1. When what? When EMFs are equal to case 2, when EMFs are subtracted, when EMFs are subtracted. What do you mean to subtractive? When negative term is connected to negative only. Okay. So when negative is connected, you add it. So then, what the circuit? How to draw the battery connections? This is the battery connections like this. Please try to remember. This is the battery. We got subtract. Same elements, negative and negative. So then you can say, what I can write is E1, E2. Okay, sir. Then it is a subtract. That I can say, if I move from this one, otherwise better I can change the number if I need out in that. So now wait. What I can do the connection, I can change now. I do the changing in connection. So this is the positive terminal. This is the negative terminal. And this is the just I have to change. Again, this is the positive terminal, negative terminal. The same terminals are connected common. It should be like this. I'm entering here E1 minus leaving, this is E2. So when you move from entering E2, so E1 minus E2, then only can believe it again. So is equal to the length is L2. So this is the equation 1 and equation 2. When the cells are additive, when the cells are subtractive, then you are getting the relation. After copying up, then what the formula are getting? So therefore, E1 plus E2 by E1 minus E2 is equal to L1 by L2. L1 by L2. Now I want to E1 by E2 is equal to L1 plus L2 by L1 minus L2. So with respect to this, with respect to EMF ratio. Copy this. How you got cross multiply? Simplify, you get it. E1 by E2 is equal to L1 plus L2 by L1 plus L2. Okay. L1 plus L2 by L1 minus L2. Copy all of you. We will close this. Okay. 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 Right. Correct. Right. Next, determination of internal resistance of a cell. Right. Next concept, determination of internal resistance of a cell. Determination of internal resistance of a cell. Now write all of it on the circuit diagram. This is the potentiometer Y, AB, switch K, EM of E. Now I am taking resistance R, external resistance load which is R, battery of EM of E, and the resistance small R. Okay, sir. Now I take again same two-way switch. Okay, this is the two-way switch. Okay, now it's the same thing. This is the galvanometer G, and the resistance box is mustard should be there. Now, when switch is in the position 1, I can call it the position 1. We call it position 2. Position 1 and the position 2. This is the position 1, the position 2. And this is the value 1. And move the jacket from, what do you call it, say, A to B. At the one of the instant, the galvanometer source IG is equal to 0, current is 0 ampere. Then denote the length as L1. This length is L1. And in the position 2, the length is L2. Then the position 2, the length is L2. You can jagging it. So now this is L2. So this is galvanometer 0, current is 0. Now, R is now we want to find that the internal resistance R is equal to, this is the actual resistance, R into L1 minus L2 by L2. This is the direct formula. L1 minus L2 by L2. Okay, sir. Right. So this is the now completed. We go to the problems. We go to the body. Conclusion of sound type. There is no end for this. Take this problem. Take this problem now. Right. A potentiometer has problems, please. A potentiometer has. Take the problem. Question. A potentiometer has uniform potential gradient. Uniform potential gradient. Uniform potential gradient. Gradient across it. Across it. Full stop. Two cells connected in series. Two cells connected in series. Series in the point 1 to support each other. What do you mean to support each other means adding the EMF to support each other. And number 2, to oppose each other, to support each other, to oppose, next point number 2, oppose each other, are balanced over 6 meter and 2 meter, 6 meter and 2 meter respectively on the potentiometer wire, respectively on the potentiometer wire. Full stop. The EMF of the cells are in the ratio of, the EMF of the cells in the ratio of, the EMF of the cells in the ratio of. When is adding the length which you got is how much? So what you are adding L1 is equal to 6 meter. when you are subtracting, E1 is equal, L2 is equal to 2 meter. Okay, sir. Then they are asking you the ratio of EMFs. Tell me. E1 by E2 is equal to E1 by E2 is equal to మళ్ళీ చేయండి అదే మళ్ళీ పంపిస్తారు కాబట్టి తెలియదు మళ్ళీ పంపిస్తాను ఎంతమ్మా Nana. What is the answer? Right. Right. So that is E1 by E2 is equal to E1 by E2 is equal to L1 plus L2 divided by L1 minus L2. This is the formula. Yes, ma'am. This is what? 6 plus 2, 8. Now 6 minus 2. This is the 4. So 4 to the answer is the ratio of E1 and E2 is equal to 2 by 1. That's all. What is the E1 and E2? If you want, so E1 and E2 you want to find. E1 by E2 is equal to 2 by 1. 2 by 1. The total EMFs are not given. So E1 by E2 is equal to E1 by E2 is equal to 2 by 1. That's how we can do that. Understanding? If you really want, anybody want to find E1 and E2, what to do? So E1 plus E2 is directly 6 and E1 minus, then from this also you can find it. What is that? So if you add it will be cancelled. 2E1 is equal to how much? Adding of 6 plus 2, 8. Therefore E1 is equal to 4. Then E1 is equal to 4. What is the E2 value? 6 minus 4, 2. That's all. So 2 volt, 4. Understanding? Very good. If you want E1 and E2, right over. So next go to next problem. So next problem, please take. Right, sir. In a meter bridge, next problem. In a meter bridge, the balancing length from the left end in a meter bridge, the balancing end from the left end is found to be 20 centimeter. Is found to be 20 centimeter. Full stop. The value of unknown resistance is 20 centimeter left hand. So the value of the unknown distance is, this is the left gap, this is the right gap. Now this is the left gap, okay sir, this is the right gap. So from this the balancing length they are given 20 centimeter. So I get a 20 centimeter. If they are given in centimeter, then this is a 100 minus 20, 80 centimeter. So this is the P This is the Q or X you can say. Center point. Right. Now what they are asking? So they are asking the found to be the value of the unknown resistance. This is the unknown resistance X. Now P by Q is equal to P by X. You can say P by X is equal to R by S. Okay. Then this is cancelled. 2 1s are 2 4s are. So the unknown resistance value how much? X is equal to 4. X is equal to 4 ohm. P is equal to 1 ohm. You remember the meter bits, the balancing length from the left hand.
Slightly less than 4.
No, small gap. Right, please stop. So in left gap, a standard resistance of 1 ohm, right, in a left, sorry, in a right gap, in the standard resistance of 1 ohm resistance in the right gap is 1. In a meter page, the balancing length from the left hand is found to be 20 centimeters. The value of the unknown, but what is the value? The standard resistance of the 1 ohm is in right gap. So they are given the question again. Okay, this is over. No need to worry about it. Complete it. These are 4 ohm one. Please complete.
So 4 ohm kani takku undali.
Relation P is equal to 1. Q is equal to 1.
First adi balance.
Second one. A by B is equal to 2 by 3. What is the A value?
Okay, first balance ga anuko ఇది balance lo లేదు. So first balance ga anuko
Balance length is 20 centimeters given. Read the problem. In a meter page, the balancing length from the left end is found to be 20 centimeters. What is the other end? 100, because we made 100 to 20, 80 raised to 1. Then what is the unknown distance value? So this is the unknown distance value you are going to assume. We also we don't know, but assume the unknown distance value. So P by X is equal to R by S, 20 by 8. Answer 2 1 to 4. What is the unknown distance? 4 ohm. So resistance, how do you know, sir? You may have a doubt. Resistance is directly proportional to length. More length, more resistance, length. That's all. This is simple. They are directly proportional. And in ratio, A by B is equal to 2 by 3. What is the value of A? 2 only. What is the value of B? 3 only. That's all. Now, again, this problem I can remodify it, then you can see what I have to do. Please write this. Another problem. In a meter bridge, another problem. In a meter bridge, the balancing length from the left end, within a bracket, standard resistance of 1 ohm is in the right gap. Standard resistance of 1 ohm is in right gap. Close the bracket. Is found to be, close the bracket, is found to be 20 centimeter. 20 centimeter. Full stop. Then the value of unknown resistance is. So that problem is over. Now this is my left gap. This is my right gap. Okay, sir. This I called just rough diagram. This I called P. This right gap I call it as Q, and this is the length of the magnet wire, 1 meter AB. They are telling that the balancing length from left hand is 20 centimeter, and another, that means automatically 80 centimeter. There is no question. Next. Now this is, they are kept in a standard distance is 1 ohm, they kept it. So which is unknown? P is unknown. So therefore P by Q is equal to R by S, 20 by 8, 1 by 2. So therefore this value is 1 ohm, standard distance 1 ohm. Now, therefore, P is equal to 1 by 4 into 1. 1 by 4 is equal to 0.250. Are you understanding, all of you? Right. Completely. Now go to take next problem. All of you completed up. So last the question. Can we I take this one, please. 219. So last time they gave a revision with principle, just see that how they are. Very simple only. So this book is enough to prepare all. No need of all, no so many books. Learn concept, go to the problem solving. So then you know what type of problem. So in a NEET 2025, they are given this question, Pearson Bridge problem. Please tell, explain. Now choose the correct circuit. Please write. Choose the correct circuit. Choose the correct circuit. Choose the correct circuit which can achieve the balance bridge. So I have to draw 4 circuits, please. And please try to draw the book. This is the A option. So I am drawing parallelly. You can tell current immediately. This is the 10 ohm. This is also 10 ohm. This is what you call a diode is there. Diode of this resistance is 5 ohm. This is a 15 ohm. Okay, sir. Which is very close. And it is EMF is E. This is A bit. And B also same thing. Try to draw the diagram first. So diagram drawing time taking. For me, no way. Not present. Can go. Same. This is the diode like this. Now diode is like this. I have to draw the diagrams. The 15 over. Permission चला होता है बाबू ना तो पूरा सीमा होता है so the battery match ये तो करना काम होता है उस प्रकार का करना डायोड observe this carefully, which is the balancer mode. So choose the correct circuit which can achieve the balance bridge. Balance, bridge balance or balance bridge. Among they are given 2024. Are given 2024. Please tell this one which option is correct. This is a D. Anybody can do it? Okay, I try to do. Just another. So this is the diode. P by Q is equal to R by S. 10 by 10. This is the forward biasing. No problem. So because 10 by 10, 15 by not equal. This is unbalanced only. So forward biasing, no problem. Here is 10 no, 10 no. This is a reverse biased. So no current flows. This is unbalanced only. No. 10 by 10. This is a forward bias. Director 0. Same one. Okay. So the circuit which can achieve the bridge balance. Bridge balance. This is a reverse bias. Reverse bias. P by Q is equal to R by S. Which one, anybody? First option. First option, what is that? So 10 by 10. by Q or R by S? 15 by 5. What are asking? Choose the correct circuit which can achieve the bridge balance. How? Bridge balance is current pass galvanometer 0. Oh, right. Current passing through galvanometer 0. Yes, sir. Yes, sir. So look here. This is forward biasing. That circuit only. Then current flows. Infinite current flows. So it's a line only. So that is a zero resistance. So that becomes zero only. Okay. So current is zero only. Now coming to this is a reverse bias. Now see the battery is a reverse bias. So now there is a completely open. The resistance also not there. So correct. When this is that, the current then how much current is going to flow through the galvanometer? Zero current flows. Zero current is going to flow. Now D see here this is a 62 second. Yeah. Here there is no current flows, no chance to balance. This is a reverse bias, no chance. This is also no chance. First option correct now. It is going to be balanced, not balanced, but going to be achieved to balance. Along one side I consider of this when the E there, the current flows reverse bias connection, no current. There is no chance to become a balance because completely reverse bias. So this is the next. Go to the third one. See, this because of forward bias, this is the complete resistance is zero. Zero resistance with it is zero, completely zero. No chance to become, no chance to make to achieve balance one. Now coming to this one, EMF battery positive this side is there. So this is a reverse bias completely. There is no part of here. There is no trying to become reverse. So finally, the one at which because this is a forward bias, current is going, I can able to balance this one by adjusting the EMF. So option A is correct. Option A is correct. Okay. All of you understood? All of you understood? Next. Take this. Okay, Nana. Take this one, 2020 NEET. A resistance wire connected in the left gap. A resistance wire connected in the left gap. Connected in the left gap of meter bridge balances 10 ohm. Balances 10 ohm. Balances 10 ohm. Resistance in the right gap at a point which divide the bridge wire. At a point which the bridge wire in the ratio 3:2. In the ratio 3:2. Full stop. Full stop. If the length of the resistance wire is if the length of the resistance wire is 1.5 meter, then the length of 1 ohm resistance, then the length of 1 ohm resistance wire is 1 ohm, resistance wire is so this is the problem. Please once you go yourself, a resistance wire is connected in the left gap of a mirror bridge of 10 ohm. 10 ohm resistance in the right gap at a point which divide the bridge in the ratio 3:2. So this is a 3:2. This is 3 parts. This is the 2 parts. 3:2. If the length of the resistance wire is 1.5 meter, then the length of the 1 ohm resistance wire is. That's the question. Okay, sir. So once you go, a resistance wire connected in the left gap, okay, 10 meter, 10 ohm resistance in the left gap. At the point which divide the bridge wire, the ratio 3:2. If the resistance of the wire is 1 meter, 1 meter. ఇక్కడ resistance of L is equal to 1.5 meter. Then the length, the 1.5 meter, the length of 1 ohm is. So first we have to find this one. 1.5 meter. So to become a balance, the resistance is this much. That is equal. The length is 1.5. What is the length of 1 meter or 2? First you find R, unknown distance. So P by Q is equal to R by S. Nothing is there. So 10 by unknown distance R is equal to 3 by 2. Nothing I'm writing. So now cross multiply. This is a, therefore R is equal to, listen all of them. R is equal to how much? R is equal to 20 by 3 ohm. So this gives you of length how much? 1.5 meter is equal to 20 by 3 ohm. Therefore 1 meter is equal to how much? What to do? Divide with that. So please see here. So therefore 1 meter is equal to 20 by 3 into 1 by 1.5. 1 by 1.5. So remove the decimal point, take to the numerator 10. Then you can say 5 3 the 5 4 the. Okay. Now that is 40 by 9. So 9 4 the 36 and 4.4. Oh God, this is wrong complete. Okay, I did a little mistake. What is asked? So 1 ohm is how much length? Sorry. 1.5 ohm is this much, this one. Now I did the reverse. So this is also one point, is okay, no problem. But what I just 1 ohm is equal to how much length? Directly proportional, you can multiply and divide it. So 1 ohm is equal to how much length they are asking? That is, so 1 ohm, how much length they are questioning? 1.5 by unknown length x is a meter. We don't know. Is equal to 20 by 3 divided by 1. Therefore, x is equal to, take this for x. Okay, 1.5 into 3 divided by 20 is equal to x meter. Now you get it. Now this decimal 200. Now here is 15 3 is 45. So 45 by 200. I can go with this one. 2 2s are, okay, 2 2s are 4 and 5. 22.5. That is 22.5 into 10 to the power of minus 2 meter. Answer. Otherwise, I can write 2.2, just I am moving, 2.25 into 10 to the power of minus 3. This is the answer. So we want to find length, not resistance. This is the correct. Okay? Correct. Okay now?